do archery, and I have a bow similar to this. It's called a recurve bow. Now the thing about these is you need to be able to aim your arrow in the right direction, point it the right direction, and know the angle to hold your bow at to be able to get it to reach far enough. So keep that in mind for a moment. So what we would have would be, let's just make sure that works. We would have a flight path. Now I'm going to do the best I can for a drawing. Goes up like that and down to the target. Alright, now that's meant to be symmetrical about the center line. It isn't, but pretend it is. That is actually a quadratic curve. See, so you could use the quadratic, the conditions of the quadratic, to work out the angle you would need to get the projectile to go far enough to be where you want it to be. This is the sort of thing that they use when they're firing a cannon or something like that. They need to know the angle to put the cannon at to get the projectile to land where they wish it to be. That's just one example of the use of a quadratic. You'd also get it involved in engineering and all sorts of other manufacturing process and relationships, but that is an immediate one that comes to mind, and one that you will probably be shown in school as an example. You need to get used to the format of y is equal to a times x squared plus bx plus c. C is a value that doesn't change. As in the overview, that's where the graph crosses the y-axis. B is a number. A is a number. Those two, they don't change. X is the one that changes. Right? This is the general form equation of a quadratic. Now from that, what you will be asked to do in schools and so on is to factorize that. You may also get involved with something called completing the square. And you will quite likely get involved with solving for where the graph crosses the x-axis, which in fact that does. And also, no, that one does something different. So this would be x is equal to minus b plus or minus the square root of b squared minus 4ac, and the whole of that is over 2a. So it's just a matter of substituting in your values in this here. What we're going to be looking at in this video is this one here. One point I forgot to mention, polynomial, poly is many, nomial, number, many number. If your first term, your highest power, if you like, is a square, it doesn't have to be x, then you have 2 brackets. If it is cubed, you have 3 brackets not going there, and obviously if it's 4 factorizing, you would have 4 brackets. Okay, so this is the one we're going to be looking at here. Starting point. Let's put a line. Oh crumbs. Let's put a line down here. I'm going to start at the answer just to make sure that the question is correct. All right. What we need to end up with is y is equal to x plus 2 times x plus 3. Now I'm going to work this out. You've probably seen me do this before, but it wouldn't hurt to do it again. Let's change the colour of some of these, shall we? Let's change the X there to that colour, and we'll change the 2 to green. Alright, so yes, that's a 2, that's an X. How do we multiply that out? Everything in that bracket is multiplied by everything in that bracket. If there's nothing in front, it means it's positive. So that is a positive X. That is a positive X. Dealing with this one first. This X here, positive X, times that bracket. So we have that positive X times the bracket and everything that's in it, because the bracket is grouping things. Right, so that would equal, I think I've got this line in the too far over to one side. Let's just remove that and go back here and white. Okay, x times x, that is x squared. Positive, positive, so that is positive. 3, x times 3. There's your 3, so it's 3x. Positive times positive, so that is positive. That now has dealt with that one. We're now going to deal with the 2. Okay, so we have 2, which multiplies everything inside that bracket. So we have x plus 3 equals 2 lots of those is 2x. This is the column for x's, so that's 2x. Positive, positive, the signs are the same, so that is positive. 2 times 3 is 6. We haven't got a column for just numbers, so we make a new column. Positive times positive is positive. Add those together, we just get 6. 3 lots of x put with 2 lots of x gives me 5 lots of x. That's positive. That is just x squared. Alright, so what we're looking for is to be able to convert that back to that. So we're looking for x squared plus 5 x plus 6. We want to factorize that. This is in fact y equals. So that should be y equals as well. What it means is that there's 2 numbers. Suppose we have, I'll just pick on some letters, some value, and I'm going to give it the letter I. Another value, we're going to give it the letter J. IJ. That could be different values, they may be the same. We need it such that this here is wrong way round. Yeah. Well, I suppose I could change the order, it doesn't matter. I plus j. Whatever values those are, add them together, we should get that, because that is what it's doing here. There is that. 3x plus 2x gives me 5x. I and j. So I could be 3, j could be 2. Alright? But we don't know. We're pretending we don't know what they are. That one is I times j. So we need 2 numbers that when multiplied together give me 6, but when they're added will give me 5. Now let's look at a factor tree. We have 6. Now I can split that into 1 times 6 will give me 6. But I can split that further into 2 times 3. 2 times 3 is 6. That matches that. Do they add up? 2 plus 3 gives me 5. So in fact those are our factors. So what we have here is y is equal to, here's our two brackets, x and x. They're both cases, they're positive, so it is plus 2. That one there, plus 3. That now, there, matches that. That is your factorisation. Now, this works well if there's only a 1 in front. Now remember, 1x, we don't bother to write the 1, we just write the x. Okay, that's an example of factorisation. Now, what does that actually mean? What does that mean? Let's get rid of that, shall we? My pen's squeaking a bit. This is positive, so it's an upward opening shape like that. And as it happens, this one will cross the x-axis. There's your x-axis. We're looking for the y value when the y is 0. The x-axis crosses the y value when it is 0. So it is the point where this curve crosses the x-axis there, because y is 0 at that point and y is 0 at that point there, where x is that point and x is that point, y is 0. So for this to be 0, either that one can be 0 or that one could be 0, because 0 times something gives you 0. Alright, let's consider this one here being 0. X plus 2 would equal 0. That means if we take the 2 over the other side, shortcut method, x equals, take the 2 over the other side that equals, do the opposite process, positive that side, or add, so the opposite is subtract. X is equal to minus 2. Consider when this one equals 0, we have x plus 3 equals 0. X equals, take the 3 over to the other side of the equals, do the reverse process, it is add on that side, so to subtract. So we have a condition where x equals negative 2, and the other condition, x equals negative 3. If x is equal to negative 3, that is minus 3 plus 3, which is 0. If x is equal to negative 2, that is minus 2 plus 2, which is 0. We have found the points where this graph crosses the x-axis. Now the minimum, as it's that shape, it's a minimum, is at the midpoint between those two. It is exactly in the middle. Exactly in the middle. And if we do this, we have minus 2 put with minus 3 divided by 2, and that gives me 3, 4, 5 divided by 2 is minus 2.5. So the x value there of the minimum is that x is equal to minus 2.5. That's what factorisation is all about. Now the ones I'm going to be dealing with all have a 1 in front of the x. It will only be x squared on its own. It would not be something like 3x squared, you know, or there will not be a shown number in front of the x unless I put a 1 there. We are not dealing with that type of thing. We're dealing with this type of thing here. There'll be a 1, although it's hidden, it's there. There's a 1 in front of the x. It's saying we've only got one of them. This works fine for that. Let's do another one. My blackboard moved, so that may be in a different position. So what are we going to look at in this example? Let's take a look at y is equal to x squared. We're sticking with just the one of those. We're not going beyond the one of those. Plus 24x minus 81. I've mixed the signs. Previous example, they were both plus. This time one of them is minus or negative. Okay, we're looking for two brackets. Because there's only one of those, we know that it is x, x, and because it is positive, they're the same sign. Now they could be negative times negative. That would give a positive. Or they could be positive times positive. That would also give a positive. But keep an open mind. We'll see if it works considering those as being positive. We'll keep it at that. Okay, we want here two numbers that when multiplied together give 81. When you add them together, they give 24. So that means that the one that is minus or negative, this one here, I'll call that J, call that one I. Because we are subtracting and we end up with a positive, this one here has to be greater than that. That's written I is greater than J. All right? That means, I don't like the word bigger, it's wrong. It is greater than that. And it is positive. Okay, so let's look at 81. 81. Now we want two numbers that when multiplied together will give 81. Well, 8 plus 1 is 9. Now that immediately tells you, because 9 is completely divisible, exactly divisible by 3, 81 is divisible by 3, exactly. We're only dealing with integer values, whole numbers. We're not dealing with fractions, we're dealing with whole numbers. Different ball game if it's fractions or decimals. Whole numbers. Okay, now look, in that case, one of the numbers that would divide into it, a prime number, is 3. 3's into 8, well we can fit two lots of 3's in 8, because 2 3's are 6, which is less than 8. There's a 2 to carry. Now we got 21. 3 times 7 is 21, so it's 27. 3 times 27 equals 81. Get rid of that. Can we split that further? 7 plus 2. Oh, do we need to split it further? Whoa. Have a look. If we add 3, it becomes greater than 27, so that's no good. If we subtract 3 from that, it becomes 24. No. 27, remove 3, 4, 5, 6, 7, so that's 4, 24. So in fact what we've done now is we found the numbers that multiplied together would give me 81. And if we put them together like this, we get 24. That means 3 is negative. This is positive. So what we end up with here is minus 3. And that is 27. Now there's a slight problem with this. It's not completely factored. Is it completely factored? Yes, it is, because we can't, yes, that, we can't divide that by 3. We can divide that by 3, but we can't that, so that's it. We can't take it any further. So y is equal to that. Okay, what does our graph actually look like? Yeah, before we go there, for this to be true, this has to equal 0, or this has to equal 0 for y to equal 0. It can't both be 0 at the same time. For that to be 0, x must be plus 3. So we would have our graph like that. One point will be plus 3. There's your axis, x-axis. That one there will be plus 3. For this to become 0, x has to be minus 27. So that will be minus 27. Now we would expect that the axis is oh crikey. Let me try and do a straight line. Let's pretend it is totally symmetrical about that. This point here, the x value would be between those two there. So we would have 3 minus 27 over 2, which in fact is, yes, is equal to minus 24 over 2, which is equal to minus 12. Okay, so let's have a look, shall we? I'll bring my graph across if I can find it. And whoa, there we go. Let's reduce its size a bit. Can we do that? Yeah. Come on, move. Thank you. What's that say there? 3. Look, plus 3. We expected the other one to be 27 minus 27. There you go. Is it minus 27? Yes, there you go. So that is minus 27. Now the vertex, the point where it changes its slope, is somewhere around about there, and I said that was minus 12. So let's have a look at this here. We want x equals minus 12, and I want it to be a dotted line. Where are you? Come on, I've lost my cursor now. It's on the other screen. And dotted line. That looks about right. Oh, you can't see it. It does say minus 12. Hang on, let me bring that down here. There you go. Point of intersection, the x value is minus 12. Okay, so you have found, or we have found, the key points. We have found the x value, minus 12. It's halfway between those two. We have found what each one of these is as regards the value of its x. This is the sort of thing you would be expected to do. Now this value here is the x value there. If you were to substitute that for x there and there, and work it out, you would get your y value. That's what factorisation is about. One more thing I want to show you. Do I take it there? No, I don't. Okay, we're still working with that just being 1 there. Watch this a few times. Right? Play with some numbers. Build something from that to your equation, then see if you can factorize it back to what you started with. Practice and playing with is how you learn. Just reading, say, yeah, I've read it, that's fine. You won't learn. Actually do it.